Faults in power systems sound frightening only until you realize that the entire electrical grid is designed assuming things will go wrong. Welcome to the Learning Studio, where we don't just teach subjects, we break them down to their core intuition, so you understand why systems are built to survive failure, not just how diagrams look on paper. Most students think fault analysis and protection systems are niche topics meant only for power engineers, but in reality, they exist to answer one critical question. What happens when something goes wrong? And how fast can we stop it from becoming a disaster? Electrical faults, like short circuits, overloads, or equipment failures, are inevitable in large systems, and protection systems ensure that these faults do not cascade into widespread blackouts or damage. To see this intuitively, think about a fuse in your home. When too much current flows, the fuse melts and disconnects the circuit, protecting appliances and wiring from damage. The same idea scales up in power systems. When a fault occurs on a transmission line or transformer, protection relays detect abnormal conditions, and circuit breakers isolate the faulty section within milliseconds, keeping the rest of the system operating safely. At a deeper level, fault analysis helps engineers calculate fault currents, understand how voltage and current behave during abnormal conditions, and design protection schemes that respond accurately and selectively. Protection systems must act fast enough to prevent damage, but selectively enough to avoid unnecessary outages, which requires careful coordination and precise analysis. On a larger scale, fault analysis and protection systems are the silent guardians of national grids. Power stations, substations, industrial plants, and renewable energy installations all rely on layered protection to maintain stability and safety under unpredictable conditions, such as lightning strikes, equipment aging, or sudden load changes. In real engineering practice, these concepts are applied when setting relay parameters, selecting circuit breakers, coordinating protection zones, and ensuring compliance with safety standards. Decades of engineering experience and standardization have shaped modern protection systems, making them one of the most critical aspects of reliable power system operation. Now that the intuition behind fault analysis and protection systems is clear, the next step is to explore power system stability and dynamics, where engineers ensure the grid remains synchronized and stable even after disturbances. And that's exactly what we'll cover next here at the Learning Studio.